University of London, Imperial College London, and the Czech Academy of Sciences. He's passionate about biodiversity in many forms, particularly in how it's being affected by environmental change and what this might mean for public health and vector-borne disease. In the Northeast, ticks and associated diseases have become an enormous public health issue. There are a few groups of people that are more aware of and exposed to tick-borne diseases than birders. So tonight, he'll be discussing how ticks are, I can't believe he said this word, embedded in the wider ecological community. You did that on purpose, didn't you? And the relationships they have with birds, and attempt to debunk some of the myths around tick-borne disease. He'll present some possible solutions and would like to have some open, engaging discussion, and he means that, on how to make our local birding less risky. So please join me in welcoming Joel Brown for Ticks and the Ripple Effects of Disease on Ecological Communities.
Well, thank you very much, everybody. That was a wonderful introduction, and I am very privileged to be here in front of you tonight because the reason I'm here is pure happenstance. I told some of your associates at dinner, but the reason I'm here is because of a redneck grebe that was near Dryden Lake back in the spring that me and my buddy went to go look for, and some of you were all there, and we met, we crossed paths, and people learned that I worked with ticks and decided that might be an interesting thing for one of your presentations this evening, and boom, here I am. So, yes, as Stephanie very kindly introduced, I will talk a little bit about ticks in an ecological context, and then I will also do a little bit of myth busting regarding tick-borne disease, because yes, I work with ticks, and yes, unfortunately, there is a lot of misinformation out there, and I partly consider it a duty of my job to sort of be a public servant in that regard. And with all that said, I have to start with a very important caveat, which is I am not that kind of doctor. I'm the doctor of philosophy thinking kind of doctor, some might argue useless doctor, not a medical doctor. So with that being said, though, I still know a good deal about tick-borne disease, and I hope that that means you'll trust what I have to say a little bit more than a random post on the internet. I have deliberately withheld as many gross images as possible. It's Monday night, we've all had dinner, we can keep it PG. I will start on the ecological side, and then we'll get more towards the medical side in as much as I am qualified to talk about such things. And hopefully bust some tropes, introduce some terminology, and I will try and keep it as birdy as possible. I appreciate most of your talks are probably all about birds. This is not about birds, but I can do a little bit on that. So, ticks in the eastern US, there is something of a big three. This first one is the black-legged tick. It's Ixodes scapularis. It is the smallest of the big three, quite literally. This is the one that I'm sure nearly everyone in this room will have seen and probably on them. They are disgustingly overly familiar around here. And you can see on the little diagram the difference in the life stages. They get really, 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 really small. If you think small, think smaller, and then that's how small they get. They are found in very forested habitats like this one that you can see here. If you want a bird analogy, think somewhere where you might hear a red-eyed vireo or a wood thrush. That's the kind of habitat we're talking about. You can also see that they are widespread across the eastern US, and they don't really make it into the western parts. They are now also pretty widespread into Canada. They have been spreading north because of climate change, as has the next of our big three, the Lone Star tick, which is also widespread in the eastern US, but a little further south compared to others. It is much bigger and more aggressive than Ixodes scapularis. It has eyes, and it will physically kind of hunt down its host. It sees something and will just scarper towards it. They can move surprisingly fast for such an evil little critter. They are found in much more scrubby habitats that you can see in this picture here. So think something like a brown thrasher or an eastern towhee. And I feel that it's particularly important to address lone stars because we are based somewhat on the frontier of their range. So in a New York State context, lone stars are very well established on Long Island and around the city, but they have not yet made it much further north. Most people, unfortunately myself included, here to give you the bad news, think that's a matter of when, not if. It is pretty likely that within the next 10 years, they will be establishing themselves in Tompkins County and our surroundings. This map here is where, is all the counties marked in green where a Lone Star tick has been sent for testing, i.e. someone in that county has found one and decided, oh, that's weird, and maybe it was on them, it might not have been, but either way they found it. Now, an important thing that I will get into later is one does not equal a population, much like a migratory bird. I know back in the spring there was a blue grosbeak that showed up at someone's feeder for a few days and then it disappeared and never came back, sort of like that. What's the word? Incidental, that's the word. There is a birding word for this. A lot of these reports will be incidental, but it's only a matter of time before they're not that incidental. And the third of our big three is literally the biggest, and is the American dog tick, Dermacentor variabilis. And these are really quite big as adults. Like, they're pretty hard to miss. They are also widespread across the eastern United States and somehow weirdly also California. I don't really know what explains the giant gap in the middle. And they are open grassland dwellers, so think where you might find a bobolink or a meadowlark. And the big three might be about to become a big four, because we have a nasty little invasive species, the Asian longhorn tick, which is native to Eastern Asia, like China, Korea, Japan, but was introduced to the US in 2017 and has slowly spread its way around the Northeast as well. And a real difficulty, let's say, with them is that the females can reproduce without mating. So when they do show up, you tend to find them in incredibly dense numbers. And from a public health perspective, it's a little bit to be determined. So in the native range, they're actually mostly known for spreading a disease for cattle. So this is more of an agricultural issue rather than a human issue. But there is increasingly anecdotal evidence here in the US that some of our native pathogens here can be picked up by Asian longhorn ticks and potentially transmitted as well. So I don't know about their spread. Like, we probably have a little while to enjoy the relative peace without them being in Tompkins County, but they could very well end up in Tompkins County too. Now, from a biological perspective, ticks are balloons with mouth parts, and that is it. There is nothing more interesting about them. They are just a bag. They are a bag waiting to expand. This is about the grossest picture that I'm going to show you tonight, by the way. Like, that's as bad as it gets. Their simplicity is almost disgusting in how effective they are at doing what they do. And the bag of blood that they become is kind of how they develop through their life. So I'm now going to show you a life cycle. So you start with an egg, the egg hatches into a larva, the larva becomes a nymph, and then the nymph becomes an adult, the adult feeds, and if it's female, well, unless it's an Asian longhorn tick, it also mates with the male, and then with its massive bag of blood that it acquires for itself, it produces thousands of eggs. And one single female, regardless of species, will generally produce thousands.
What's the size?
Of the
one filled with blood, the large one.
Think maybe middle fingernail.
Okay.
Once they're expanded. And And so basically to progress from each stage of its life cycle, it takes a blood meal. That is usually just one. So the larva will attach onto something, it will take a blood meal that lasts about a week, and then it channels that energy into developing into a nymph. And that's how they change. It is very unlikely that any tick would take 2 blood meals. That would only happen if it got detached for some reason. So if an animal successfully knocks it off, then the tick has not acquired enough, if it's somehow still alive, and then will eventually end up seeking out another host. This life cycle tends to take about 2 years to complete, and because it takes 2 years, we get a lot of overlap between different life stages, and this is where things get complicated. It is also not helped by the fact that ticks are incredibly generalist feeders by and large. They have slight preferences, but the general rule is if it has blood, it will try and feed. And so here we have how the life cycle looks different. So this is a life cycle of seasonal activity for the black-legged tick, the Ixodes scapularis. So if we follow the black line, the solid black line, that's the adults. They tend to peak in the spring, and then they somewhat disappear over the summer, and then there's a second peak in the fall, like where we're at right now. So actually, right now at this time of year is prime time adults again. There's a peak sort of April-ish, and then a second in October. If we follow the dashed line, that's the nymphs. They peak very much in the late spring, so we're talking May, June time, and then they just steadily decline for the rest of the year. And the larvae have more of a slower peak where they end up peaking towards the end of summer, and then they also kind of precipitously drop off. And I'm focusing specifically now on the black-legged tick, Ixodes scapularis, because they are often referred to as the deer tick. But the association with deer is a bit misleading. If you look closely at this deer's ears, you can see that there are some ticks attached in there. And actually, when you're out and about, especially when you're carrying your binos, if you do see a deer, have a look at its ears and you will probably see one, or several, most likely several. They are called deer ticks because there is a strong association between this particular tick species and white-tailed deer. And that is part of the reason why deer management is an increasingly important activity. One, to reduce the tick populations, and two, so that we don't hit them with our cars. And there's plenty of other reasons as well. That's what happens when we got rid of all the natural predators of deer. The entire system's out of whack, and the ticks are benefiting from the system being out of whack. But one of the reasons that the association with deer is a bit misleading is because the deer are actually rubbish reservoirs, and by reservoir we mean an animal where the pathogen can survive but also replicate of various tick-borne pathogens. So what I mean by that is, if an uninfected tick feeds on a deer, it will not acquire that pathogen, and if an infected tick feeds on a deer, it may transmit that pathogen, but nothing will happen to the deer because of it. And therefore, that deer does not create a link in the chain that leads to us getting sick. The animals that are good reservoirs are these three. The white-footed mouse takes the gold medal for sure. Chipmunks take the silver, and then shrews in the genus Sorex, they take the bronze. And it is hard for me to overstate just how incredibly effective white-footed mice are as reservoirs of tick-borne disease. So if a mouse gets Lyme disease, effectively Lyme disease, it will last in that mouse for months, and then any other tick that feeds on that mouse is almost certain to pick it up and then drop off, and then it develops, and then we have more and more infected ticks in the population. More and more infected ticks means more likely we get infected by a tick bite, and that's just how this thing keeps on rolling. So one of the tropes that I hear a lot is about winter, and you may have heard this a lot. So one thing that I hear all the time is, oh, it was a bad winter, so there's going to be a lot of ticks this year. Like, well, yes, but also not really. And I'll explain what I mean by that. Those of you that have lived in this region for long enough will know a lot better than me, and I've already experienced it a bit, that snowfall has decreased dramatically compared to how it was a few decades ago. And especially the last couple of winters that we had, 23 and 22, have been appallingly bad for snow. And if there was consistent snowfall, the way that it used to be like 3-4 decades ago, snow's actually very insulating. And if the ground was covered by snow 4 or 5 months of the year the way it is normally, anything that's underneath that is actually very temperature stable, including the ticks. So the ticks were actually used to having a lot of snow cover. And actually the winters that we've experienced more recently, where there's like a bit of snow and then it melts almost immediately, freeze thaw, freeze thaw, freeze thaw, that's actually good for killing off ticks because the ground is not covered. So if it thaws, tick becomes active, and then it freezes again, tick dies. Maybe. Or like increasing chance of tick death. The flip side of that is, because of the more variable winters, that means we've had much warmer temperatures in December, January, February, and into March than would be considered normal. I remember especially earlier this year, in February, it was almost ludicrously off the scale compared to what was considered normal. That means there's more tick activity. So whereas not so long ago, we used to be able to think of Lyme disease as a seasonal disease, now it really is a 12 months of the year issue, unfortunately. There are people in our local community who have managed to acquire Lyme disease on New Year's Day and like right in the middle of winter, where you definitely think there should not be ticks active. Wouldn't you know it, there are. And the other thing, just to make it even worse if that wasn't bad enough, the more variable winters has resulted in more ticks surviving winter, and for reasons that remain undetermined but have been discovered by a colleague of mine in Nova Scotia, where they do know a thing or two about winter, the ticks that survive better are the ones that are infected with Lyme, the ones that are carrying the agent of Lyme disease. So joyous for us. The other thing that you should know related to ticks and sensitivity to their environment is that they are incredibly sensitive to humidity, much more so than temperature. So the reason that ticks have such an association with leaf litter is because that is a nice humid environment, and they can just tunnel away into the leaf litter, be able to maintain essentially their osmotic balance, like not dry out essentially. And rather than winter, one of the best predictors of tick die-off, or the opposite, is the conditions in the spring. So if we have a dry spring, that's a very good sign that a lot of ticks will have died. If we have a dry spring with a heat wave, that's an even better sign that a lot of ticks will have died. However, there are very valid reasons why a dry spring heat wave is perfectly bad for a lot of other things. So as much as I want to say dry spring heat wave good, I know it's not for so many other organisms. Okay, now I'm going to talk a little bit about ticks and birds. So, I know, all waxing. With birds, rather than with mammals, it's a little bit more of an open question that a lot of people are getting increasingly into researching. And so one of the things that happens a lot is people discover that they have ticks in their backyard and they're like, what can I do about this? I'm going to buy chickens to eat the ticks. And it's like, yeah, kind of works. And some people get really clever with it and they buy helmeted guinea fowl. And there's a paper from 1992 that suggested that helmeted guinea fowl were like the holy grail answer for controlling Lyme disease. And it's like, yes, but no. They were a little bit right, but also not completely. And this paper gained something of a cult status in the community. So basically, the number of adult ticks was lower when helmeted guinea fowl were around, but the number of immature ticks, the nymphs and the larvae, was the same. So it's not really making that much of a difference. And there was also a new study from last month which suggested that immature Ixodes scapularis, so again that black-legged tick, fed on birds 42% of the time, which was actually higher than even mice. So that they could be on birds more than anything else. I don't know if that's necessarily generalizably true. I think that could just be a finding of that particular study. But this was a very large study that was essentially a side project of misnetting a whole host of migratory birds, and they found more than 70 different species of birds that had at least one Ixodes scapularis larvae attached to them. That's quite a lot. So then that would suggest that birds are significant players in spreading ticks around and potentially spreading disease around as well. But it's not as easy as that. So the next slide I'm going to show you are the main avian culprits of potentially spreading Lyme disease around. And it's these guys. Usually the thrushes are blamed pretty heavily, and that's not just here in North America. Blackbirds in Europe are blamed for spreading ticks around a lot as well. Essentially the common denominator is anything that likes to feed on the ground is more likely to pick up ticks. But for whatever reason, these 6 species in particular seem to have an ability to retain the bacteria that causes Lyme disease a little bit better than any other bird does. I think it's a bit unknown why. I'm just throwing that information out there. And so the next slide I'm going to show you is a rather crude graph showing the average number of ticks along the x-axis and then the quality of the reservoir organism on the y. So if we start down here, I said before that white-tailed deer are actually rubbish reservoirs, which they are. So they have a lot of ticks on them, but they are poor reservoirs. Mice are kind of both. They have lots of ticks on them, and they're good reservoirs, very good. Chipmunks are somewhere more like here, and then something like an American robin is down this end. They don't have that many ticks on them, and they're not that good reservoirs, so that would suggest that they're actually not that important in spreading ticks and spreading disease around. However, you know much better than I do just how many robins there can be around, and I think this is one of those situations where the sheer flood of numbers, the sheer volume of birds that can show up in the spring and in the autumn in particular could actually sway the discussion. And migratory birds definitely are bringing ticks. That's just accepted, yeah, at this point. The million-dollar question is how consequential is that movement of ticks? And so there's now a whole host of excellent research groups focusing around the Gulf of Mexico. And again, you will all be aware, I'm sure, that a lot of migrants show up there in the early spring, which is what this is just showing on a loop. And one of the magic numbers that I've seen was an estimate that birds coming from Central America across the Gulf are bringing 19 million tropical ticks with them every spring. And most of those ticks will show up if these birds are misnetted somewhere around the Gulf when they first make landfall in the US. The general explanation for why certain ticks have not established here in the US is a matter of temperature, and probably a matter of dumb luck as well. But again, that's something of an open question. How long will it take before something does establish? Because there's evidence to suggest from across the Atlantic Ocean, where I'm from, that has happened. That birds migrating up from Africa into Europe have brought ticks with them, and those ticks have established in Europe. So, bit of an open question. We can talk about it again later. I'm now going to shift into the more diseasey side of things. So this is where things get gross, if it wasn't gross before, but hopefully also informative. I really, really, really hope this is informative. So tick-borne diseases account for somewhere between 3/4 and 95% of the annually reported vector-borne disease cases in the US. By vector-borne disease, that means something that you get from a tick, or a mosquito, or some other kind of biting fly, or a bedbug, or anything that feeds on blood, basically. Of that percentage, Lyme disease accounts for about 70% of all of those. So that's a lot, but that still leaves 30%, so there's wiggle room here. It's very important to understand that Lyme disease is an important disease, but it's very much not the only tick-borne disease. There is also a belief that Lyme disease cases are underestimated by a matter of tenfold. So if there were 50,000 in a year, which is not a reasonable guess at all of what's actually reported, it could actually be 500,000. And there's an argument to be made that that would still somehow be an underestimate. And co-infections within a tick are very, very common. That's an issue I'm going to loop back to in a bit. Right now I'm just going to overview the main different diseases that we have to worry about. So the big one, Lyme disease. You can see from all the purple dots on the map that it is very much concentrated in the northeast and the upper Midwest. A lot of these other cases are probably more like travel-based cases. So the Floridians picked it up in New York, maybe, and then went back to Florida for the winter, as people tend to do. This is caused by the bacteria Borrelia burgdorferi. It is transmitted by the black-legged tick that we've been talking about already. The main symptoms of Lyme disease are fever, headache, chills, muscle aches, and fatigue. And I want to draw your attention to one little nugget about data, which is that you can see here by my mouse that Massachusetts is showing up grey, largely, amongst a sea of purple, purple being the cases. That's not because Massachusetts is magically Lyme disease free, it's because they stopped counting, because there were too many. And the CDC is well pissed off that Massachusetts stopped counting, because it's really messing with their numbers, and then it really messes with their map. And I can kind of understand why, if I worked for them, I would also be annoyed. But that gives you actually quite a good sense of scale of the issues that we're dealing with here. The Massachusetts State Department of Health are like, screw it, we're not counting anymore, it's too common. Another one is anaplasmosis, caused by a bacterium called anaplasma. You will notice there will be a theme developing here. This is also transmitted by the black-legged tick, and it also causes fever, headache, chills, muscle aches, and fatigue. And it also is concentrated in the northeast and the upper Midwest. And then a slightly different one, because we're moving to something transmitted by our friend the Lone Star tick. It's called ehrlichiosis, transmitted by a bacterium called Ehrlichia. Again, causes fever, headache, chills, muscle aches, and fatigue, but you'll notice it's concentrated a bit more in the south, because that is where Lone Star ticks tend to be most common. But as I said before, Lone Star ticks have moved their way north, and they are very much established on Long Island. There are parts of Long Island that are heinously overrun with Lone Star ticks. Very good chance of picking this up here. This is also a good aside to mention, whilst it's not technically a pathogen, because it's an allergy, this is the tick that causes the red meat allergy. So for whatever reason, a certain percentage of people, when they get bitten by multiple of these ticks, suddenly develop this intense immune reaction that pops up whenever they eat red meat. There is no known cure for this. It's something that you will have for life. And it tends to happen when the little guys, the larvae, a bunch of them just latch on at once. And it just, I can only assume that it means that your body is essentially flooded with some sort of immune response, and then something just changes and it sticks. That is commonly referred to as alpha-gal syndrome, but it's actually an autoimmune disease technically, because it's an allergy. Not a pathogen, and that makes it exceedingly hard to track. Again, going back to the data issue, if you show up at the doctor's and you're like, I ate steak and now I feel terrible, they're probably going to assume it's something else first of all, and you're going to have to eat a lot of red meat to prove that it's this, and to make a clear association, but it's very hard for that to end up in publicly available records, basically. Like these maps that I'm showing you, there is no decent map of alpha-gal, but just know that it's a risk, and know that that's a good thing as to why we don't have Lone Star ticks here, and the longer we keep them away, the better. And so, another one, rickettsiosis, caused by a bacteria called rickettsia. And this is transmitted by the American dog tick, again concentrated more in the south, but you can get it in New York, although it is rare here, I will admit that. Again, causes fever, headache, chills, muscle aches, and fatigue. And similarly, now shifting onto an actual parasite, we have one called babesiosis, caused by a parasite called babesia. Another disease, yet another disease transmitted by black-legged ticks, that also causes fever, headache, chills, muscle aches, and fatigue. That's also concentrated in the upper Midwest and the Northeast. And then the last of the main diseases that I'm going to show you is a virus. It's called Powassan virus. It is also transmitted by black-legged ticks, and it is also concentrated in the Northeast and the upper Midwest. And the symptoms of this one are a lot more serious than the other tick-borne diseases tend to be. So it essentially can end up manifesting itself as cerebral meningitis. Like you get encephalitis in your brain. And this is one that is a cousin, a viral cousin of tick-borne encephalitis virus that is in Europe. The good news about that is that there is a vaccine for tick-borne encephalitis in Europe. So one can only hope that it is a matter of time before they make a vaccine for its American-based cousin. And you'll notice that I played emphasis on the symptoms there, and that's to make this point. The diagnosis of tick-borne diseases is difficult because the symptoms are so similar, and because co-infections are common, and then also there's difficulties about molecular diagnosis that I'm not going to go into tonight, but just know that they're there. And that's what makes separating the truth from not the truth very difficult. And so I'm now going to jump into a process of attempting to myth bust about tick-borne diseases as much as possible. I'm hoping that it will jump ahead of some of the questions that you may have rattling around your brains now. So number one in my myth busting is that Lyme disease can be cured. You would not believe the amount of times that I have been asked, because I've had Lyme disease, that's a good time to reveal that, by the way. I got it here 2 years ago, and it was the most unbelievably classic case of Lyme disease that you could ever possibly imagine. It looked like someone stamped the Target logo on my back, where I had the bullseye rash. And yes, I did feel unwell, and yes, I did get treated for it, and no, I don't have Lyme disease anymore. It is not like HIV or Huntington's disease or Parkinson's. It is not a lifetime diagnosis. So that one is something that I have to make clear wherever I go. You very much can get rid of it. The second point is that it is very possible to actually have Lyme disease, but to test negative for it. That's what we call a false negative test. That is partly because the standard test will be a blood test, and the Lyme disease bacteria, Borrelia, does not show up very well in the blood. I can verify this using myself, because I just said I had it, and boy did I have it, a really clear-cut case of it, and yes, my test came back negative. I could not believe that my test came back negative, and it sent me down this rabbit hole that led to me working on ticks to this day. It is also very possible to have Lyme disease but not exhibit the bullseye rash. The bullseye rash is considered the definitive diagnosis of Lyme disease. If you look like you have a Target logo stamped on your body, you have Lyme disease, and you can go to the doctor and get that treated real easy. But that only comes up in about 80 to 90% of cases. So not everyone that gets Lyme disease gets a bullseye rash, and unfortunately those are the people that we have to worry about, because unless they develop symptoms and start feeling unwell, and unless they are aware that they received a tick bite, those are the people that could go untreated, and then everything can get a bit more serious. The other very common, or another, it's not the other, another very common myth to bust is that transmission of pathogens to us does usually take hours. There is a term thrown around by doctors and the internet and circles wherever you look really, that it's a 24-hour rule. That's not a strict rule. It's not like if you knew somehow that a tick had only been on you for 23 hours that you don't have to worry about that. No, still worry, but it's something of a sliding scale. Think of it as a sliding scale rather than a binary rule. Earlier this summer, I had a tick on me that had been on me for a maximum of 7 hours, and it was embedded on me, and I was fine, because it was only 7 hours. The one that did give me Lyme disease, I never found, and that is such a cliched case of many people that end up sick from something to do with ticks, is they find the other ticks, and then there's somehow one that they don't find, and that's the one that makes them sick. Another myth to bust is that there are other species of Borrelia bacteria, not just the causative agent of Lyme disease, and some of them are other tick-borne pathogens, including another one that I didn't show a slide for because it's not that common, but it is possible to get around here, and it is caused by a sister species of Lyme disease. It's called Borrelia miyamotoi, and it causes hard tick relapsing fever. And that does what it says on the tin. You get a fever and then it goes away, and you get a fever and then it goes away. And it is largely treated the same way, but yes, it is yet another tick-borne disease to worry about. And now I'm going to go on to the big one, and this is the one that's most controversial, and usually the people want to know most about, is because this is all over the internet. There is something on the internet, and that people will have learned through various means, and they will ask me questions about it. And the question is, what about chronic Lyme? And the term chronic Lyme is not liked by the medical community because it is something of an unknown, and also because it is misleading. So this is the official term, is post-treatment Lyme disease syndrome, PTLDS. And this is something that is attributed to a patient who was diagnosed with Lyme disease, was given the course of antibiotics, and after their course of antibiotics is feeling unwell again. And the reason that the CDC and the medical field does not like the term chronic Lyme is because it implies that the reason the person is still feeling sick is because there is an ongoing bacterial infection in their body, and that is not necessarily the case. It could be the case, but this is unproven at this point. And that's why we prefer the term PTLDS, because there can be complications, but I should stress that if you have had Lyme disease and you got better and then started feeling worse again, it's not necessarily that you still have Lyme disease. It is worth noting and emphasizing even that it could be because of the antibiotics, because for Lyme disease and for any tick-borne disease really, the standard prescription is a drug called doxycycline. I've had it, sounds like other people in the room have had it based on that reaction. It is a gnarly drug, and they tend to give it in courses of 42, so twice a day for 3 weeks. That is a long time to be on any antibiotic, and that can very easily cause some lasting damage to your body that has nothing to do with the infection that you got from a tick. We are in an era of science and medical science where we are understanding more about the microbiome, and that not all bacteria are bad, and actually quite a lot of bacteria are good, especially those that live within us and in our guts especially. We need those. Taking a 3-week dose of incredibly hardcore antibiotics is going to do a number on that. And so one of the most sensible bits of advice that I can give is that if you are put on doxycycline because you are either legit suffering from a tick bite or because your doctor suspects that you have something and has given you the course anyway, do the course and do as much as you can to look after your microbiome, basically. So that means eating foodstuffs that are microbially active, like yogurt, often have good bacteria in them. Like, do what you can to look after yourself, in as much as the fact that you can look after yourself when you're taking incredibly hardcore antibiotics. Whew. Sorry, that was long. I also, you'll see in the bullet point there, have to separate out the whole long-term untreated Lyme and the post-treatment complications. So this term only applies if you have had a course of antibiotics and you are still feeling unwell afterwards. There are also those who, as I mentioned, because they might not have had the bullseye rash and because they might not actually develop many symptoms, they might feel a bit unwell, but it could be like, oh, allergies. They go untreated, and then Lyme disease can continue to progress within the body, and then more serious symptoms manifest. And that usually takes weeks to months, could be months and months later. But this includes symptoms like serious brain fog, really serious fatigue. Arthritis is actually a very common one, especially of the knees. And even something like Bell's palsy. Like partial facial paralysis can happen because of this, if Lyme disease goes untreated. And that combined with the flu-like symptoms that you tend to get in the beginning if you do develop symptoms straight away, that's a lot of different symptoms to worry about. And so when you think about it, it's like, okay, there's a lot of different symptoms, and then you have to worry about the side effects of the antibiotics, and then you have to worry about ongoing complications afterwards. Like, there's a lot of layers to this. And this is the worst kind of cake. This is not a good layer cake. This is intensely difficult. The other that has absolutely nothing to do with disease that is still relevant, and is still relevant for me to myth bust, ticks can't jump. But they can appear to jump. There are intensely, deeply macro-lensed videos, slow-mos, where ticks can appear to jump using static electric. And I've worked with dead ones, and it still happens. I kid you not. Because in the plastic vials that a lot of my ticks, my dead ticks, very dead ticks are housed in, if you take them off, sometimes they can just jump out. It's dead. That was nothing to do with the tick, it was just the static. But live ticks can do the same. And so if you are out and about and you happen to find a tick, let's say on your arm somewhere, and you're like, what the hell, how did you get there? It probably fell off the tree. Or you brushed past vegetation. If you didn't brush past any vegetation that was up to your arm, if you were in very low areas and there's still somehow something up here, and you're on the trail, came out the tree. So with all that being said, and having probably scared people in the audience shitless, which wasn't my intention, I promise. Here are some sensible precautions for you when you are out birding. And I do not want to tell you from your birding, this is a very committed birding organisation, and I love how committed birders tend to be to their craft in general. Keep doing that. Don't let me dissuade you. Not trying to dissuade you. So when you get home, put clothes in the dryer. That's a really good one. High heat, 10 minutes. Any tick that could be in your clothing is roasted, as it deserves to be. Kill them. And do very thorough tick checks in the shower. That sounds like a really obvious one, but I have to say it anyway. Let's keep it simple. Do very thorough tick checks. It's annoying. Suddenly every mole on me, I'm like, you get to learn yourself, let's put it that way. The third option, as modeled by me here, is to take a piece of tape for quick tick removal. So I do this when I'm out actively sampling ticks, but this is not necessarily something that has to be reserved for people who are actively sampling ticks. Just clear tape, fold it over so it makes a loop, and you can just leave it stuck to your clothes up here. And then if you happen to find a tick on the outside of your clothing whilst you're out and about, just a quick, got it, and then it's safely stuck on the tape. Also using bug spray, especially around your ankles and tucking clothes in. That includes shirts into pants and pants legs into socks. That all helps. Understanding the habitat as well. I mentioned at the very beginning of my talk, I showed different images of the habitat that different ticks are found in. That is something of a clue. It's not a perfect fail-safe, but if you are doing a bobolink count in open grassland, be aware of dog ticks. Probably not going to get Lyme disease from a dog tick. Almost certainly not, actually. That doesn't mean that there's not the outside chance, but the risk levels scale. It all scales around. Those of you who have pets, please take preventative measures with your pets if you don't already. That does make a really big difference. There is a Lyme disease vaccine available that is used for dogs, and I think one of the ultimately good news bits of information that I can disseminate this evening is there is a Lyme disease vaccine for people that is in the final stages of clinical trials, which I think is an incredibly good sign that it made it to the final stages of clinical trials. So I would guess within 5 years, and that's me being modest, it could be sooner, we will have a Lyme disease vaccine that's available for us. Of course, that will be a massive game changer if and when that happens. I think that is a when, not an if. The other is yard and garden management. So one of the easiest and most visually pleasing ones, it's not like destroy your garden or anything, is a barrier of wood chips or gravel between your lawn and any wooded area, because ticks can't cross that. I don't know why, but they just can't. Reducing the height of the grass, so you don't have to be super frequent about mowing lawns, but be like somewhat frequent. Also stacking wood neatly and in a dry area to discourage rodents, because the rodents are what's really bringing the ticks, and likely the infected ticks as well. And also keep playground equipment and decks and patios away from the yard edges and away from trees. And if you want a fairly newish piece of control that it's very environmentally friendly, it's benign to anything else. Again, my colleague in Nova Scotia was delighted to tell me about this one. Balsam fir needles and essential oils from those needles are really good at killing overwintering ticks. So since we're approaching winter time-ish, it's kind of on the horizon, it's coming. You can do that in your yard, if you are in any way paranoid about ticks being in your yard. Balsam fir, who knew? They knew, and now I know, and now you know. And lastly, I want to focus on what to do if you are bitten. If you do get home and there is a tick embedded somewhere on your body, first thing, try and remove the tick. That sounds like stating the obvious, but do try and remove it. It's not like embedded piece of glass, just like, do I take it out or leave it in? Do try and remove the tick, but only with the proper tools, which are a pair of tweezers or a tick spoon, which you can see modeled in the lower picture there. At that point, I have to say, please do not use petroleum jelly, a hot match, a lighter, nail polish, or any other folk remedies to try and remove your ticks. You might succeed, but at what cost? Especially with the lighter. After you have removed said tick, clean the bite site with either rubbing alcohol or iodine, or at the very least soap and water if you don't happen to have the others available. Also, try and keep said tick if you can, if you have a vial or a Ziploc bag or any sort of just enclosable space that you know that you can put the tick into, and it's not going to crawl out and you're going to show it to your friend the next day and be like, oh God, the tick's gone, and it's now somewhere in my house. That is very, very useful in case you do start to feel sick later. You can send the tick off, or even just show a photo of the tick to an expert who can be like, that's that tick, it probably carries that thing. If you're feeling unwell, it could be that thing. There we go, like, useful information is being passed around. Of course, monitor yourself for a rash. I mentioned the Lyme disease bullseye before, but some of the other diseases that I have mentioned today do cause a different kind of rash. Or any symptoms of sickness, those were the flu-like symptoms that I showed before. And if prescribed antibiotics, this is a very general one, but it's an important one, please, please, please complete the entire course. I told you I had Lyme disease myself, so I was given the 21-day course of doxycycline. I was feeling completely normal-ish, or like symptom-free by day 7. So if I had a different mind, I could be like, well, I feel fine, I'm going to stop now. And no, don't do that. Just finish the entire course. And also, when you remove the tick, I missed this detail, try not to break it. If you're going to grab it with tweezers, grab it as close to the skin as possible. Don't just try and twist it off, because that's how the tick breaks, and you can leave the mouth parts embedded in you. And if the mouth parts are embedded in you, it can still be transmitting a disease to you. Okay. Lastly, if you want to take pictures of this slide, please do so. Here are a bunch of hopefully very useful external resources. So in the middle here we have the Tick app. This is free to download. It was developed by colleagues of mine at Columbia University. It is a very useful app. Also available are the SUNY ESF up in Syracuse Tick Lab. For $75, they will test any tick that you send them for 16, I think it is now, different pathogens. There is also the Tick Encounter Lab at the University of Rhode Island. I know we are not in Rhode Island, but you can still use them because we are in the Northeast. It's largely the same environment. They will test any picture that you send them for free. That's useful. And then of course, locally we have Cornell's Cooperative Extension Unit, and we also have the Northeast Regional Center for Excellence in Vector-Borne Diseases based out of Cornell. The professor who is the director of NEVBD is a fantastic researcher. Her team does amazingly good work. They do excellent online resources as well, so in case you are worried, very trustworthy resource. I will just mention, because I said about the sending off ticks thing, that please don't let that be an excuse for paranoia. So what I mean by that is, if you find a tick on you and you're like, don't like that, I'm going to pay the 75 and I'm going to send it off and get it tested. If it comes back that that tick was positive for 1, 2, 3 different things, that doesn't then mean that you have the things. It means you might have the things, depending on how long you think it was on you, but don't treat it as a guarantee. Okay, did it. Lastly, I am actually going to cycle this back to birds. I would like to wish you all happy birding and remind you that checklist ticks are better than real ticks. And this is a perfect loop back to those that I had dinner with earlier. My favorite bird is an osprey, and that's why I included my favorite picture of my favorite bird. And I will now gladly take your questions. Thank you very much for listening. Yes?
We've been using the tick-borne tool to remove ticks, and we kind of twist it around. Is that okay?
Well, it's a specialist tool, so yes. Yes?
Oh, thank you. I want to thank you for doing this and the Bird Club for doing this. I think this should be done more often to warn everybody. I was a birder when I was younger, and then I started birding here. I'm from Sweden, and I started birding again here in America maybe 5-6 years ago. And I never heard of any of these dangers.
Mm-hmm.
And I got a bunch of these diseases: ehrlichiosis, babesiosis, Lyme disease, and symptomless, except for a flu, bout of flu-like symptoms, just like you mentioned. But there's one thing you didn't mention, which is that there can be permanent side effects.
Yes.
The nerves in my toes have now died. You can cut me with a knife and I won't feel anything. And there's no, medical science apparently doesn't know, this is my first question, medical science apparently doesn't know how that happens medically, how the tick can give you this side effect. And that's one thing I'm curious about. You know, I'm doing a lot of physical therapy and things like that to help prevent deterioration, etc. But it's a lifetime, it's a life sentence.
Yeah.
It's certainly a permanent effect of bird watching if you don't watch for a tick. And the other question, I have some questions. The other question is, you didn't mention permethrin. I've understood that's one of the very best things, or the only thing, some people say, that you should have your clothes treated with so that ticks won't stay on them but fall off before you even notice them maybe. So
that's true.
That's one thing. And if I can squeeze in another question. So I was a very intensive birder when I was a teenager, a young person in Sweden. Sweden, we have a lot of ticks all over the place, but I never got sick with anything. I also wonder if there's an age difference. Is it more dangerous when you get older to get these ticks, whether in Europe or in America?
Okay, I will answer your questions backwards. So the first or most recent question was about if there's an age effect with any of these tick-borne diseases. I don't know. There could be, but somehow I doubt it. I think it depends more on your immune system.
Your immune system as you age diminishes. So you may be able to not be able to fight the same way.
Yeah. The middle question was about permethrin. I'm being pedantic and I consider permethrin just a bug spray, but I know it's applied differently. So permethrin is a much more intense liquid that you apply to the outside of your clothes and your shoes. Don't apply it to the inside because it is pretty
Toxic.
Yeah, toxic. I didn't want to use the word toxic for some reason, but toxic is the right word.
Which bug spray is not toxic?
Yes, well, that's true. And the first of your questions was about the ongoing symptoms that you've had.
If you know anything about the forefront of that science.
I don't, because I'm not an immunologist. I think that would be the immunological realm of disease to answer that. But I do appreciate that you shared that information because you have perfectly characterized exactly why this is, in my opinion, a public health crisis. And crisis sounds like an intense word, but I think given some of the numbers that I mentioned earlier, that it could be 500,000 people a year in the US are getting Lyme disease. That's a lot. I don't know how that compares to stuff like the flu or even COVID these days, but I think this should be called a crisis. And I don't mean that in a sort of hyperbolic way. I mean that in a sort of calling a spade a spade. Unfortunately, it is that bad, and especially when you live in upstate New York, we have a lot of these things to worry about. Yes, sir.
So what has the trend been like over the last, I don't know, 30, 40 years of Lyme?
Up and up and up.
So what happened to cause it to?
This is again where we get into the realms of data and data issues. So part of it is just that we tested for it more. So if you look at the number of reported cases, that's gone up and up and up.
Yeah.
That could partly be a product of increased awareness and increased testing for such things. But I think that is only like 20% of it, say. I think in reality, yes, there are more ticks now than there were 30 years ago. And with more ticks, there are more infected ticks. Yes?
Okay, so way back in the beginning of your talk, you mentioned about a certain tick having eyes.
Yes, Lone Star ticks, yeah.
Well, that's a really weird thing. I mean, I've never considered that they didn't have eyes.
Oh, yeah, okay. So, yeah, that's partly why I refer to them as a balloon with mouth parts, because there's kind of not a lot else going on. They have vague abilities to sense differences in temperature and humidity, and like most blood feeders, find their way to a host. And that's about all they have going on up here.
How do they sense the host?
A combination of heat and carbon dioxide, I believe. There's probably other factors at play as well, but largely in the entomological world, we're dealing with anything other than sight, which for us as humans that do rely a lot on sight is quite difficult to comprehend usually. Yes, sir.
Together we've had many ticks over the years, and I've always tried with the tweezers first, and it never works. And I mean, I pull and pull, and It is just amazing. And first of all, if I keep doing that, it's not good, right? I break it.
Yeah, you don't want to break it.
So what is it about the mouth part? They have like a little hook or something?
It's not, I don't think it's hooked in the way that other blood feeders are hooked, but it's that they sort of pierce their way through the skin like a hypodermic needle, and then they just stuff their mouth parts in and they basically create a seal. So it's kind of like a vacuum seal, and they're just really, really, really stuck in there. And actually, you're reminding me of an anecdote I know that is bird related, which is that a colleague of mine works on the Falkland Islands in the Southern Hemisphere, where there are lots of nesting seabirds, and has seen cormorants that have been out fishing in the open ocean come back to land, and on their feet they've still got ticks attached. So whatever that tick is can survive going really quite far underwater, one would assume, on a bird, and then come back and it's like, I'm good. And then, like, this is really what I mean about them being so unbelievably simple that it's kind of ingenious how simple they are. Yes.
It always amazes me that no matter how much you tuck everything in and cover up every place, kids can still find one on your belly.
Mm-hmm.
Or on your leg, but what the heck? What have they gotten through?
It is kind of, it's miraculous in the like least enjoyable way that you would want biology to be miraculous. My best guess, because I've had that happen to me as well, is that they are worming their way through the fibers of my sock. And
Worming their way through the fibers of your sock?
yeah, because I mean, if you hold your sock and like pick it apart with your nails, there's enough of a gap there, and with the Ixodes scapularis ticks especially, it cannot be overemphasized enough just how small they get. Yeah.
So I used to, with my husband, used to work in Panama a month a week later. We used to put gaiters over our socks,
Yes.
so they couldn't get in there.
Yeah.
And another thing to do is to wrap tape, to put your socks inside your jeans and then wrap tape around it.
Yeah.
Tight.
Yeah. Which then results in you overheating quite substantially.
Well, having the blood disappear from your feet.
Yeah. Yeah.
It seems you've done quite a bit of research on how they move, and that's fascinating. So could you say something more about how do those ticks that are in a tree, how do they know when to jump? And
Oh, they don't.
How do they-
There's not.
and how do they get
knowledge
on
of it.
those?
It's random.
They just,
Random?
Yeah. It's just it's almost chaotic in nature.
Yeah? How do they get onto the birds?
Onto the birds would be usually on ground foraging birds.
yeah.
So like when you see an American robin that's just hopping around the lawn, if it's not your lawn and it's a more natural grassland.
But your waxwing is way up in the tree.
It is, yeah. Ticks will be up there too. If you think, if we imagine, let's say, a larval Ixodes scapularis is attached to, say, a porcupine, and porcupine goes up the tree, and eventually tick has fed enough so it detaches, and it can just scuttle along a branch as a nymph now, and attach onto something else. I would assume it happens like that. What we really need is outrageously tiny sensors. Like, migratory birds have the little trackers fitted. We need that for a tick. And yes, sir.
What's the spotted tick, the deer tick, what's that species?
Ixodes scapularis, that one?
Working with Boy Scouts, we found them sitting on grass and leaves, and they're standing there with their arms out like this, just waiting for something to walk by so they can
Yep.
grab all of them.
That is, in the terminology for that is called questing.
Okay.
Yes, sir.
In the scheme of the universe, Do ticks do anything beneficial?
Feed someone else. That is honestly as good as I've got.
Protein for birds.
Okay.
Protein for birds is as good as it gets. Like I get asked that question a lot with regard to mosquitoes because it's a very open question. It's like, why can't we just kill the mosquitoes? Like, but if we're ranking them out, mosquitoes do more than ticks do.
Yeah.
Okay.
All right, we have time for another more question.
What about timber rattlesnakes? Yeah, what's your take on them?
They're setting me up because I told them a pet idea I had earlier. So if we recall that I mentioned the different mammalian reservoirs of tick-borne disease, the white-footed mice, the chipmunks, and the shrews, I am of the belief that not only do we need to be controlling the deer populations, but we need to be controlling the mouse populations. And the reason we have to control the deer populations is because we lost the natural predators of deer, but we have also lost, or at least significantly reduced, a lot of the natural predators of mice and chipmunks and shrews. And that would include things like pine martens and weasels and timber rattlesnakes. And if you look historically, there were a lot more timber rattlesnakes across the northeastern USA than there are now. In New York, they are officially threatened, but I feel like that's an out-of-date state designation. They're probably endangered. Across New England, they are endangered or worse. And I am of the belief that there should be more of them, which is a controversial opinion to have, because people don't like venomous snakes. But the argument that I am now presenting is essentially, what would you rather have? A potential but very unlikely encounter with a venomous snake that will completely leave you alone, unless you really wind it up, or disease from a tick?
So do ticks go after warm-blooded only?
No, they will attach to cold-blooded organisms, but because cold-blooded organisms tend to be scaly or slimy, it's harder.